Right, I want us to look at this problem that we have here. It combines both parallel lines as well as the circle. Look at the circle, this is the origin. This circle is not at the origin, therefore we use the equation to find the equation of that circle as x minus a all squared plus y minus b all squared is equals to r squared, because this circle is not at the origin. Let's look at what we have here. We've got this line as a tangent. That's important. This line is a tangent, but this line is also parallel to this line. That's also important. You must know something about the gradients of the parallel lines. So the gradient of this line is the same as the gradient of this line. Now, angifuna sibheke izinto esiyinikiwe la. Eyokuqala, sitshelwe ukuthi uline LP. LP, it is this line, LP. It's a straight line. Straight line, y is equal to mx plus c. Line LP is y plus x minus 2 equal to 0. I can write this in the right way. This one can also be written as y is equals to, you take this x, that side, it's going to be minus x. You take this to this side, it's going to be plus 2. So this is the equation of the line LP. So I do know the equation of this line. From the information that I've been given here, you can see that the gradient is negative. This gradient is negative. This gradient is negative. And what is this 2? This 2 is the y-intercept. It is the point where this graph cuts the y-axis. Where are the y-axis? These are the y-axis. So exactly where this point cuts, I know the value of this. This point here, the coordinates of this point, x la, 0, y la, 2. We got it from the equation that we are given. Furthermore, we know that we can also find this graph, the coordinates of this point. X wala singakwazi ukumthola, noma ngabe simuze or not, because we know that the gradient change in y over change in x. Since the gradient is 1 and it is negative, so the distance from here to here is 2, and the distance from here to here must be 2 for me to get 1. So if this distance is 2 units, this one is also going to be 2 units. So 2 over 2 will give me 1. All right, number 2, LP is the tangent to the circle. I think it is important that you should take note of this. If you go to your Euclidean geometry, there's a theorem that we call the tan-cot theorem. Whenever you've got a tangent, this is the center, and a radius, or even a diameter, whenever those two lines meet, you will always have 90 degrees. This is what we call a tan-cot theorem. A radius perpendicular to a tangent, it is always equals to 90 degrees. So whenever you have this situation where a line that is equal to a tangent meets a radius or a diameter, it is always going to be equal to 90 degrees where they meet. Meaning that the gradient of this line times the gradient of this line will be minus 1, because those two are perpendicular. It doesn't matter where it comes from. It can come from this position. If I've got this radius, if I've got a tangent there, this will be 90 degrees. Of course, that other side will also be 90 degrees. As I said, it can also come from this position. As long as that touches it, that is a tangent. As long as this line is a tangent, this will be 90 degrees. So it is important that we should take note of this theorem as we do our analytical geometry. Right. When they say LP is the tangent to the circle at L, so this LP is a tangent at point L. So it simply means that, but this is the diameter. So this is a radius, it meets the tangent. So whenever these two lines meet, what do we know? We know that they form 90 degrees. We are getting that from the story that they're just giving us. Now we know that the gradient of this line times the gradient of this line will be equals to minus 1, because those are perpendicular lines. The product of the gradients of the perpendicular lines is always equals to minus 1. What else are we given here? Number 3, we're told that LP is parallel to NQ. LP is parallel to NQ. These two lines are parallel. What are they saying to us? They're just trying to tell us that the gradient of this line is the same as the gradient of this line. Labo line will be the slope esifanayo. Ama slope phela iwona gradient. So i-gradient yalo line iyafana ne-gradient yalapha. Now let us try and respond to these questions. The first question, find the equation of the diameter. Let's look at the diameter here. We've got to find the equation of the diameter. This is our diameter. This is our diameter. This is our diameter. We've got to find the equation of that diameter. How do we find it? Okay. What is this diameter? This diameter is a straight line. So in other words, we are looking for the equation of a straight line. We are spoiled with two equations here. We can either use the equation of y is equals to mx plus c, or we can use y minus y1 is equals to m into x minus x1. When we use this one, you must be given a gradient and any other point. Let's check if we do have that. That is the line that we're looking for. Find the equation of the diameter LL. That is what we're looking for, the diameter LN. Here is now LN. We do have a point. Do we have the gradient? No, we don't have a gradient. But we know that the gradient of this line times the gradient of this line, it will give us minus 1. It will give us minus 1. When we take this gradient, you multiply it with this gradient, it will give us minus 1. Because these two lines are perpendicular, they form 90 degrees. Tangent meets the radius, it will form 90 degrees there. But we know the gradient of this line. We set the gradient of this line, it is minus 1. Y is equal to mx plus c. So we already know the gradient. From the equation, y is equals to minus x plus 2. We can see that our gradient is equals to minus 1. That is the gradient. The equation is y is equal to mx plus c. Y is equals to mx plus c. So m is minus 1 and c is 2. It cuts at 2. So you can see that the gradient is 1. So we do have the gradient of which line? Of this line. The gradient of this one and the gradient of that one are related. They are perpendicular lines. What do we know about the perpendicular lines? Their product, they will always give us minus 1. So the gradient of ln, gradient ln, let's see in this case, times the gradient kabani, lp, gradient lp will always be equal to minus 1. See now, the gradient lp, we do have the gradient of that line. We do have the gradient of that line from this information, because this is the equation of ln, which of lp in this particular case, which is equals to y is equal to minus x plus 2, and that gradient will be equals to minus 1. But we are looking for the gradient of ln. This gradient, we do have this one as minus 1. So this times this is equals to minus 1. Now listen here, to make life easier for us, whenever I've got a gradient, if the gradient of perpendicular lines, if the gradient of one line is 8, what will be the gradient of the line perpendicular to this one? It will be minus 1 over 8. Because when I multiply these two, I will get minus 1. Number 2, if I've got the gradient of a line as 3 over 2, what will be the gradient of the line perpendicular to this one? It will be equals to minus 2 over 3. You just find the reciprocal of it and put a negative sign. Because this times this will be equals to minus 1. Look at it. 3 times 2, it's 6. 2 times 3, it's 6. 6 over 6, it is minus 1. The answer will be minus 1. So if one gradient is minus 1, then if one is minus 1, what is the other one? The other gradient must be equals to 1, positive 1. It must give us a positive 1. Hence, we know from this information that the gradient of the diameter ln, the gradient of this diameter ln will then be equals to positive 1. Because when I multiply this and that, I must get minus 1. Let's check it. What is 1 times minus 1? It is equals to minus 1. So it is true that when you multiply the gradients of perpendicular lines, you get minus 1. So we do have the gradient now of this line, which is 1. And we also have a point on this line. You use that point. We are looking for the equation of this line. So you use the point on this line, which is, in this case, m. So we do have point m there with the coordinates minus 4 as well as 4. These are the coordinates of the point that we have there. We do have the point, we do have the gradient. This one, we do have the gradient, we do have y and x. What is x? This is minus 4, and this is y, which will be y1 in this particular case. Let's apply this formula, push it in here. We're going to have y minus y1 s equals to the gradient into x minus x1. Let's push in the values. Let's substitute. Substitution is important. Y minus, what is the value of y1 there? xy. It is 4 minus 4 in this case is equals to m is the gradient. Did I find the gradient? Yes, I do have the gradient, which is 1 in this particular case, x minus. Uba no x way to lapaya. X lo, y. X1, y1. So this is x1, so it's minus 4. It's going to be plus 4. Minus, it's plus 4. Let's check it out. Let's make y the subject. So we've got to take 4 that side. So we're going to have y is equal to the former simulator and also a positive. Remember that. So it's no banige manje. It's no 1 times x, which gives us x. 1 times 4, which gives us plus 4. Remember, we're taking this y this side. It's going to be positive 4 as well. So what is the final answer that we have? The equation of the diameter, it's going to be y is equals to x plus 8. This is the equation of our diameter in this particular case. The equation of the diameter. Let's check. Let's look at it. If this is 2, y-intercept will be up there. So it is possible that it is equal to 8. This value where this graph will catch the x-axis will be 8. Look at the gradient. Is this a positive gradient? Yes, it is a positive gradient. So we are correct. Let's look at the next problem that we have there. This next problem required us to find the coordinates of L. Kumele sithola ama-coordinates ka-L manje. Kanti siwathola kanjani ama-coordinates ka-L? Nakhu la sifuna sithola ama-coordinates ka-L. This is where L is. Asiyenzeni ke le nto. Nansi I know it's now. It's not equation yalo line. Yes, equation yalo line. It's y is equal to x plus 8. Plus equation yalo line is now in. Yes, scenario nansi lapha. So I want us to look at these two equations. This one as well as this one. These are the two equations that I want us to look at. The one that I've boxed. This is the one, which is the original one, equation of LP, and the equation of the diameter. This one, y is equal to x plus 8. Because u-L uhlangana, u-L ulapho kuhlangana khona lama equations omabili. Sazi nge-point lapho kuhlangana khona ama equations omabili, they are both equal. U-x yalo straight line lo uyafana no x wale diameter on this particular point. So we say these two equations are the same at this point. This is the only point where these two equations will meet. So they are equal at this point. What is equal? It is this graph and this graph that are equal. Now, to find point L, we need to equate those two graphs. Imaphila uma graphs ile graph x plus 8 silinganisa yiphi nayo silinganisa nale graph yethu yokuqala minus x plus 2. We equate them because we're at the point of intersection sithi ama graphs ethu ayafana ayalingana la. X wakhona uyafana no x wale enye graph no y wale enye graph uyafana no y wenye graph. Let's solve for x here. We're going to find the value of x. Take this x this side, ahlangana nalo kuzoba positive 2x is equals to, remember already have 2 this side, take this 8 this side, it will be minus 8. What do we have now? We've got 2x as equals to this times that, it is minus 6. We divide by 2 on both sides. In other words, with 2 times what? That will give us minus 6. 2 times the number enjani ezosinikeza minus 6. Low number must be negative because this one is positive to get a negative answer. So x wethu uhlele endaweni kabani ka minus 3. So that is the value of x. Our x is equals to minus 3. Bengafuneki kufuneka ama coordinates. Akufuneki u-x kuphela, kufuneka u-x no y ka L. Sesinayo x, sesifuna u-y manje. Remember ukuthi lo x lo ungamthola kule graph futhi lo x uyamthola kule graph. So you are spoiled with choice here. You can either use this equation or you can use this equation. You are spoiled with choice. I always prefer to use a positive one. You can use this one or you can use this one. Both of them will give us the same result. If we use this one, we have y is equals to x plus 8, x plus 8. Khumbula ukuthi sifuna la, sifuna y coordinate manje. Sesinayo x. Ubani x wethu in this case is minus 3. Oshuthi la khona khona x sifaka bani? Sifaka minus 3. Let's just do that. So this will then be y is equals to minus 3 plus 8. So y will be equals to, what is 8 minus 3? It is 5. Suppose I did not use this one. Let's say I use that other one. Let's see what would have happened. It's in here. It's y is equals to minus x plus 2. Uba no x wethu. X wethu is minus 3. Let's do it. So this was going to be y is equals to, you write this minus first. Then you write the value of x. You buy the value of x here. You minus 3. You push it in here. Minus 3 plus 2. What is minus times minus? It's plus. So we've got plus 3 plus 2. It will give us 5, which is exactly the same thing as that one. It doesn't matter which equation you use. They all give you the same result. Right. Let's continue with the problem and write what we are required to find. Remember here, we are required to find the coordinates of L. Otherwise, we've got to find who x got L, no y got L. What is the value of x in this particular case? It is minus 3 is 2. What is the value of y? It is 5. It is important that you present the coordinates. You don't just end here. You push it in coordinate form of L. So the coordinates of L will be that. 3 minus 3 is to 5. Let's look at the last question that I want us to do in this particular section. Remember the circle that we have here. This circle, we are required to find the equation of a circle. You go to the circle. When I look at the circle, is this circle at the origin? No, it is not at the origin. Therefore, I know exactly which formula to use. It is there in our formula sheet. It is the one that says x minus a all squared plus y minus b all squared is equals to r squared. Uma kuthiwa find the equation, usukufuna yonke into ekhona kuleyo equation ngaphandle kwa x no y. Okusho ukuthi sifunani la? Makuthiwa find the equation. Sifuna a, sifuna b, sifuna r squared. Remember, this is r squared, not r. Sifuna a, sifuna b, sifuna r squared. Asifuna into no x and no y. That's what we're looking for. But here, no a, no b. A, no b are my coordinates as center. These are the coordinates of the center. In other words, if I have a graph like this, these points here are A is to B. These are the coordinates of the center, A and B. That's what we're looking for, as well as our r squared. Those are the things that we're looking for in this particular case. Let's do this thing in conjunction with the graph. Right. From the graph, we have to find the equation. Do we know the coordinates of the center there? Ah, we do know them. These are the ones. The midpoint of that line. These are the coordinates of the center. We're given those. So it makes our life easier. This stands for A, that stands for B. Let's write them down. So what do we have here? We've got x minus. What is the value of A? You go and check x, voila, which is minus 4. Remember, this is not 4, but minus 4. You write the value of A as minus 4. You close it, then you square it. Plus y minus. What is the value of B? A, B. So the value of B is 4 in this particular case. It is equals to 4. Remember, this is also squared. It is equals to r squared. Let's write it down. Let's clean this one up. I say clean a land. This is going to be x minus times minus is going to be plus 4. This is squared plus y minus 4 all squared is equals to r squared. Khumbula ukuthi sithema sifuna equation so sifuna a no b no r squared. Sesinayo a sinayo b sishode ngo1 manje ngo r squared. Kodwa samthola kanjani r squared? We go back to our circle. Let's check what is it that we know in the circle. Ikhona into siyaziyo kule circle that is exactly on the circle. You can't take this one. This one is not on the circle. It's a center. You look for anything that you know on the circle. Remember what we've just calculated. The coordinates of L. They are on the circle. Remember, you know this point. It is exactly on the circle. So that's the kind of point that we're looking for. It is minus 3 is 2, 5. So this point, we know that that point lies on the circle because the theta is circling. So you take any point. You can either take this point if you know it or this point if you know it. You can't take the point that is inside or that is outside. You just take the point that is at the circumference, the distance around the circle. You take any point that is there. In this particular case, we are saying for us to find R, we can't have so many unknowns. We've got to have only one unknown. In this particular case, point L, it is minus 3 is to 5. Umelu x lo, umelu y lo. Let's substitute it exactly as it is. So where there is x is ufaka minus 3, you keep this as it is, and where there is y, ufaka 1 or 5, you keep that as it is. That will help us to find the r squared. Let's go. So where there is x, we have minus 3 plus 4. This is all squared plus, where there is y, it's ufaka 1 or 5. Then minus 4. It is 5 minus 4. This is also squared. This then becomes our r squared, our radius squared. That's what we're looking for. What do we have this side? What is 4 minus 3? It is 1. 1 squared is 1 plus, what do we have that other side? We've got 5 minus 4. What is 5 minus 4? It is 1. 1 squared is 1. It is equals to r squared. Okusho to r squared with u 2. So we do have the value of r squared. Now let's say scenario A, scenario B, scenario r squared. Therefore we write the full equation as it is. So we can take it from this point. It is x plus 4. 1 square plus 4 as good to A is negative. Plus y minus 4. Njoba minus 4 which to be positive. Remember, this is all squared is equals to r squared. What is r squared? We've just calculated r squared as what? As the value of 2. So that is how we go about finding the equation. So that's funa, a, b, and r squared. In this case, r squared will to 1 or 2. Remember, if the question is asking you for the radius will be the square root of 2. Thank you.